Hi guys, quick video on 3 of the properties of logarithms that we are going to use to condense equations, make them smaller, so that we can solve them eventually. So the first property of a logarithm is the power rule. So this is obviously not a power yet, but what it turns into is why the rule has that name. So the power rule says whenever there is a coefficient, like you're multiplying something to the log, that number is the power of whatever the argument is. So I would rewrite this problem like that. And so now, instead of having to figure out what the log 4 of 2 is and then multiplying it by 3, that's the same thing as just figuring out what log with a base of 4 of 8 is equal to. Right, 2 cubed is 8, so that's where the 8 came from. All right, so that's how we're going to condense a log when there's a number out front. That number out front becomes the power of the argument. All right, the next rule is called the product rule. So again, this is an addition sign. Product is what we're going to turn it into. First thing I want you to notice is the logarithms have to have the same base. If you're ever presented with a question where the logs don't have the same base, we cannot work that out algebraically. That would be something that we have to use the graph or a table or something like that to answer. All right, so the product rule says that when you have logs with the same base and you're adding them, we condense them together by multiplying. So it becomes a single logarithm and we multiply the arguments together. So that's the same as log with a base of 2 of 15. And these all tie into the laws of exponents. You probably haven't done them since Math 1, but if you remember, like when you multiply, you add the exponents together. So it's basically the just reverse order of those. All right, so the quotient rule is when your two logs are being subtracted. We're going to combine them or condense them. And again, we're only changing the argument. You notice nothing is happening to the base. The base is still the same for all of these, but we're condensing it from 2 arguments down to 1. So when you are adding your logs, it becomes multiplication. When you are subtracting the logs, it becomes division. So this is the same. 24 divided by 6 is 4. So now instead of having to do a bunch of different logs in the same problem, we condense it into a single logarithm. All right, so those are the only 3 rules that we're going to use. Obviously, you could have problems where you have to use more than one at a time. So let me just make one up quick. Trying to make one that actually comes out to be a whole number. All right, so in a situation like this, we have multiple logs, but we want to condense it down so that my final answer is just a single log with a base of 5. So you should work from left to right, but you should also be thinking about the order of operations. If there's a power rule, you have to do that first, right? Like exponents come before multiplication and division. So the first thing that I'm looking at is this 2 out front. I want to go ahead and turn that into 4 squared. To combine these 2, because that's addition, I'll have to turn it into multiplication. So work from left to right. So 4 squared is 16. 16 times 4 is 64. And then I'm subtracting the other log. So that's going to become a division problem. So 64 divided by 8 is 8. So that would be my final answer, log with a base of 5, and the only argument is 8. All right, we'll be doing more practice like this Monday in class.